This is an introduction to the setup and the operation of the EMS K850 critical point dryer. As we take a look at the front of the unit, we have our specimen chamber that's top loading. Then we have our temperature indicator. We'll be looking at this for both cooling and heating of the sample of the specimen chamber. The blue knob controls a valve for adiabatic cooling, which runs CO2 around the chamber, cooling it down to facilitate proper loading of CO2 for critical point operation. Next we have our green valve, and that allows CO2 into the chamber that then will be mixed and in conjunction with the exhaust, which is our black valve over here, will flush out the residual dehydrant out of the drain. And that's important to make sure that we get all of the dehydrant out. Next over we have our pressure gauge. It's 0 now, but we'll be looking at this to indicate the pressure to 12 to 1300 psi for reaching critical point, along with our temperature gauge. Once we've reached critical point, we have our bleed valve. We'll want to bleed off the CO2 slowly, and that's by using the needle valve. That will be about 100 psi a minute. Next we have our magnetic stir bar motor, and that is used to mix the final dehydrant in the CO2 for proper flushing during our flush cycles. Then we have our heater, and that's we'll be using that to reach our critical point. As we look at the back of the unit, we then have our power cord and on-off switch. Next we have all of our vents. We have the intake of the CO2 coming from the siphon tank. We'll make sure that's tight. We have our vent for the cooling of the chamber. Next we have our exhaust. We'll check this with filter paper for residual dehydrant. And then finally we have our bleed valve, and that'll be used for the very slow 100 psi bleeding after our critical point is reached. We have a washer that goes between the connection for the siphon tank. We want to put that in there and tighten that up, thread it on and tighten it up a little bit with a wrench to make sure. We'll check that as we open the tank to make sure there aren't any leaks after we get it hooked up to the CPD unit, which is our next step. We want to make sure that's nice and tight. Don't over tighten it, it is brass. Next we're going to take and hook up our hose to the unit itself. Again, we want to make sure that we don't cross thread it, taking care. And then we want to give that a little bit of a tighten as well to make sure that it doesn't leak. After we open our valve, we're going to be ready for our adiabatic cooling. We can see now it's only 19.4, and what we're going to do is chill the chamber down, which will facilitate more CO2 into the chamber. We want to do this. You can have your sample ready already, or you can do it before our sample. We want to get it down to about 5 degrees C. When we have that done, we want to go ahead and close for the cooling, leaving our other valves open. We have a variety of different sample holders that are available for the 850. This is one that holds 12 different samples that are relatively small. This is one that holds 12 samples that's a little bit larger. It does have a screen in between, so we don't have to worry about having samples mixed, and that's always convenient. You never want to mix your samples. Next over we have one that actually is for larger samples. It holds four, and that is what we'll be using. Next we have for cover slips. We can hold about 12 cover slips with spacers in between so we don't ruin any samples of cell cultures or anything else that you might be inserting into the CPD. We have a little weight on top of that. Then we have a holder that contains grids, approximately 15 grids or so, and this is done for TEM grids if you're going to critical point dry for a variety of different samples. We also have porous holders for particles and small devices that might be used for critical point. Next, we have containers for bulk samples, and then a larger one, and then finally we have one that contains 4 bulk sample holders. Once we have our chamber all cooled down, we can go ahead and load our sample. We want to be sure to maintain a liquid environment for the samples, whether it's acetone or ethanol. That's a matter of choice. We want to pour a little bit of ethanol into the dish so that there's an ethanol environment within the CPD holder, so when our samples go in, they don't dry out. We'll even put some ethanol or dehydrant in the CPD holder itself. It's best to just do this relatively quickly. We can just dump the samples out into a dish and then load them into the critical point dryer specimen chamber. You want to be careful that you don't do tweezer marks in your region of interest. Sometimes that's always a little bit of a challenge. Just being careful to load those from the very edge, and we don't want to again get tweezer marks inside our sample. Want to load the top, place the top of it on our sample, tighten that down, and then we'll be ready to put that into the critical point dryer specimen chamber. We'll take that over and then load it into the chamber. I've loosened the screws. Again, this has already been chilled down for the adiabatic cooling, and so that when we do add the CO2 to the chamber, it contains a proper amount. If we take a look inside the chamber, we'll also see that we have our stir bar in the very bottom. We'll use this to mix during a cycle to make sure that we get rid of all of the final dehydrant. Once we put it on there, we do want to move rapidly. We don't want to waste time, because if the sample dries out, then it's all done and the critical point dryer won't be of much use. As we do this, make sure that all of the screws are tightened down well. We don't want to have any accidents. And finally, give them a good tightening. Then quickly we want to open the green valve, which allows the liquid CO2 into the specimen chamber. And this is important. We're going to now flush our system a little bit by allowing the CO2 in. We want to check our level. We can see it's in the middle of the gauge, and we'll want to keep it there until we do CO2. Set the timer for 5 minutes and turn on the stir. We're going to stir for 4 minutes and then wait 1 minute and let the residual dehydrant settle, at which time then we'll turn off our stirrer and then start our exhaust, and that will be our first flush. It's important we're going to be doing these for a number of times. When we do the flush, we don't want to allow too much out at one time so that we maintain a good level of CO2 in the window. We're going to flush for 2 minutes, then turn back on our stir and wait for 4 minutes and repeat this cycle approximately 2 to 3 times. In the end of this, what we're going to do is check on the exhaust for any residual dehydrant. If there is no final dehydrant, then we're all ready to go. We can close all of our valves, the exhaust, the inlet valve, and even our tank valve, so we don't get any pressure bleed back. We're then going to turn on our heater and start heating the chamber up until we attain our critical point of temperature and pressure. As we increase the pressure, we can see, as we increase the temperature, we can see the pressure start to rise. And we're going to continue this. At 31.1 is our primary critical point and 1073 psi, but we're going to exceed that. We're going to attain approximately 40 degrees centigrade and 12 to 1300 psi. We never want to just minimize our point. After we've done that and we maintain about 5 minutes at the critical point, we're going to start the bleed. We open our red bleed valve, and then we're going to bleed using the needle valve about 100 psi a minute, and that would be through experience. As the time goes, we want to be sure that we maintain the critical point temperature that is above our critical point. We don't want it to fall below that, otherwise the CO2 will decrease the pressure and our sample will be ruined. So as the time goes, it's going to be about at 100 psi a minute, and we had 12 to 1300 psi. It'll take about 12 to 15 minutes for the pressure to decrease. Once we have decreased the pressure, we can turn off the heater and then remove our samples from the holder. So obviously we want to have made sure that all of the pressure was released from our specimen chamber, otherwise our top will give a little bit of a pop. There's no real reason to hurry right now. Our samples are all dry and they will be ready to mount and coat for subsequent SEM viewing. The top of the chamber may stick a little bit because of the seal that was applied to it. We can remove our sample holder and take a look at the samples and make sure that the materials are in good shape. It's always a good idea to keep your sample specimen chamber closed. You don't want any bugs or residual moisture to get in there. The easiest way to do the samples is just to open up the holder and dump them into a weigh boat or any dish so that you can contain them. And then we're all ready for mounting and viewing in the SEM. Thank you very much.